Okay, so quadrilaterals are what? What's a quadrilateral?
Four-sided shape.
Four-sided shape. Shape with four sides. Okay, so that's kind of important. What else do we know about a quadrilateral? Give me something.
Not a square.
Square is an example.
Not a circle.
What do we know about the angles?
They're
Angles.
They're not all
obtuse
90.
or acute.
Cute.
They have to be obtuse.
What do they add to? Well done. So the angles add to 360.
Absolutely great.
Okay. Shh. Now remember when we did triangles, we had... They shouldn't be talking. Remember when triangles we had right angle, we had obtuse, we had acute. We don't have those with quadrilaterals. We just have two types. We have a convex and a non-convex. Has anyone heard those words before?
No.
No? Not in science maybe?
No, we learn nothing in science.
That's not very nice. Okay, shh. Year 8. I don't need to hear a story. Shh. Nick. Focus. Nick. Shh. Bryce. Year 8. Close that now, Nick. Bryce. Okay, so a convex shape is a shape that has four sides, or well, a quadrilateral has four sides. All the inside angles are either obtuse or acute. They're all less than 180. Okay, so all angles are acute or obtuse. Okay, for example, this quadrilateral here, okay, which is some no-named quadrilateral here. It's got four sides. All those angles are either acute or obtuse. So this one here looks like it's more than 90. This looks less than 90. It's just a normal quadrilateral. Okay, so we also have shapes that are non-convex.
Non-convex.
Non-convex. Now a non-convex shape contains an angle inside it that is bigger than 180. What's an angle bigger than 180 called? Reflex. So it has a reflex angle. Except I can't spell today. Okay, so this shape also has four sides, but quite clearly this angle in here is well and truly bigger than 180. Okay, so it contains a reflex angle, and we would call that a non-convex quadrilateral. Okay? All right, the special quadrilaterals. I want you to try and remember the names of some of them. Someone's already mentioned one. Square. Rectangle.
Rhombus.
Square.
Trapezium.
Rhombus.
Parallelogram.
Trapezium.
Trapezium.
Okay.
What else did we say?
I just said
Right.
diamond.
No, I'm pretending I did not hear the word diamond. We are in maths. We do not have diamonds.
Oh,
We
yeah,
have
we do
heights.
now.
What have we missed?
Parallelogram.
Parallelogram.
Oh, that's what I said. Oh, did you know this? Yeah.
We're missing one. Rectangle.
That's what. That's just like that. Okay.
Quiet. Shh. Quiet. Okay, in each of these shapes, they all have their own special properties. Okay, so square's the one you're most familiar with. What are some of the special properties of a square?
They live under the sea.
All angles are 90 degrees.
All angles are 90.
Woo! All like they're all parallel.
They're all opposite sides of parallel. Beautiful, Bryce.
What
What are we missing?
They're
Nick,
Yeah, Nick, one of those.
what are we missing? Opposite sides are parallel, I've got right angles, what else?
They add up to 360.
All of them add up to 360.
All of them.
What's special about the sides?
They're
all equal.
They're
parallel
all equal.
lines.
Yeah, again.
All equal. Okay, and there's actually something special about diagonals for a square. What do we know about the diagonals?
They're diagonal.
Oh, look at that.
They're exactly equal. They cut each other exactly in half,
Oh,
and
that's
they meet at a right angle. So they're very, very special diagonals. Okay, what's a rhombus?
Oh, it's a square, not though.
It's like a pushed over square. Okay?
It's a badly built square.
It's a dodgy square.
It's
Okay.
like a diamond on its side.
It's kind of room.
Quiet.
Like a diamond on its side, miss.
It's a diamond on its side. Cut.
Cut. Yeah, we don't use the word diamond in maths, we use the word cracked. Okay, so I still have all four sides the same. I still have opposite sides parallel.
Yeah, I do. But your sides aren't 90.
I don't have 90, but I do know that opposite angles are equal to each other.
So there will be 360.
They all add up to 360. We've had that. What about the diagonals?
Ah, my finger.
Now my diagonals are not equal. They're not the same size, but there is some special things about them. What's special about my diagonals?
Parallel.
They're parallel
They're not
lines.
so
They
parallel.
never meet.
No, clearly they meet right there, Charlie. What's happening there?
Oh, those. Oh, look.
They cross.
They cross
They
that.
probably ran at 90 degrees as well.
They cross at 90. They also cut each other exactly. Charlie. They also cut each other exactly in half, which is called bisecting. So they bisect each other. Alright, trapezium.
What's the trapeze?
What's special about trapezium?
Doesn't
They
it
look
have
like trampolines.
it has two parallel sides.
It's a pyramid cut in half.
So like
A trapezium only has one pair of parallel lines. So in my shape, the end ones, they could go out, they could go in, they could go straight down. I don't know what's happening with them. All I know is that this pair are parallel. The diagonals, there's nothing special about them. The angles, nothing special. All we have is one pair of parallel lines. Although we do like parallel lines because then we can do like our co-interior angles and that's kind of cool. Okay? I like that. So, that means that these two here are co-interior and that add up to 180, and these two here are co-interior and add up to 180. So that's kind of special, but that's it for a trapezium. Okay?
That's insane. Incredible.
These ones are not necessarily the same. No, one could be really long, one could be short, one can come back, all sorts of things. We don't know anything about them just by knowing it's a trapezium. But we know those angles are 180, those are 180, and that's a parallel. That's it. All right, what about a kite, which is not a diamond, Charlie? It's a kite. Okay, look at my pretty diamonds. Okay. In the diamonds, it's not the opposite sides that are the same. We don't need to sing. Thanks, Callum. I'm sure that they'd love you to join the choir. We have our adjacent sides. Remember, adjacent is the fancy word for next to. So the sides next to each other are equal. And my diagonals, now this one's cut in half, but this one's clearly not cut in half. Matthew, is it? Because it's really long down here and short up here. But they do make a right angle. What about the angles?
They're pretty weird.
This angle and this angle are equal. Okay, so the opposite angles are equal to each other. Okay? Oh, they're not equal. Okay, so just these ones are equal. Shh. Quiet. So in a rhombus we had both pairs equal. In a kite, we just have one equal. All right, parallelogram. What's that one?
2 sets of parallel lines.
2 sets of parallel lines. And what about the angles?
How about the angels?
They all add up to 360.
They could be 90, but they don't have to be. So they could be basically like a knocked over one.
I
Okay?
just like a rhombus.
What's different about parallelogram to a rhombus?
That one's longer.
They're not all four the same, are they?
Yeah, they're not all on that.
But technically, that's a very special parallelogram, isn't it? Yes. But parallelograms could just be longer or taller. They don't have to have all
Does that mean
four
like
the
a
same.
rhombus is kind of like a tilted square, but parallelogram is like a tilted rectangle?
Yeah, it is.
Good boy.
Okay, so a rectangle is really a special parallelogram because it has right angles. So we've got parallel, we've got
It's
equal.
my Mrs. Lawrence.
Come on. So we've got opposite sides, parallel, equal. Anything else special? Oh, because we've got parallel lines, we've got co-interior again, which we like. Co-interior here. They're 180, they're 180. Also, they're 180 and they're 180, which is kind of cool. We have opposite angles being equal. Got all sorts of things going on in a parallelogram. The diagonals are not going to be the same length, and they're not going to meet at a right angle, so they're not particularly special. Matthew, you need to focus. Last one, rectangle. What's special?
It's like a parallelogram with right angles.
Basically. But because they're equal,
And don't they like cross?
it also gives us some special things about diagonals, doesn't
Yeah,
it?
I told you that. They're the same directly in the middle.
Alright, so that is like the worst diagonals ever drawn.
Oh my god.
They don't meet at a right angle.
You know there's like a cheat code.
Quiet.
Yeah, there's a cheating.
Cheating, not cheat code.
I can see it. Thanks. That was just not appropriate.
That was inappropriate. Don't know what happened.
Really disappointed. They're my Quiet. The diagonals are the same length and they bisect each other. They don't meet at a right angle, but they are the same length. At least they would be if you used a ruler. And they meet. They cross each other exactly in half. So just remember that's called bisecting. But they do not meet at a right angle. Remember we've got opposite sides, parallel and equal. We've got right angles, we've got diagonals bisecting, but not at a right angle, and that's it. That's our properties. That's quadrilaterals, done.
Leave it, I'm not
Woo!
done.
Oh, why?
Alright.